Hello guys, my name is Jerome Bayani from BSIT 2105, and for today's video is all about summarization of chapter 6 in CCNA 1 entitled Network Layers. So let's get started. So this chapter focuses on the role of the network layer. It examines how it divides network into a group of hosts to manage the flow of data packets within the network. It also covers how communication between network is facilitated. This communication between network is called routing. The network layer is the network layer or OSI layer 3 provides service to allow any device to exchange data across the network. To accomplish this end-to-end transport, the network layer uses four basic processes. These are addressing end devices, encapsulating, routing, and the last one is the encapsulation. So, addressing end devices must be configured with a unique IP address for identification of the network. The encapsulation, the network layer encapsulates the protocol data units or the PDU from the transport layer into a packets. The routing is the network layer provides service to direct packets to the destination host on another network. The last one is the encapsulation is when the packet arrives at the network layer of the destination host, the host checks the IP header of the packets. So network layer protocols is are several network layer protocols is existence. However, as there are only two network layer protocols that are commonly implemented, and these are Internet Protocol version 4 or the IPv4 and the Internet Protocol version 6 or the IPv6. Encapsulating IP is the transport layer segment or other data by adding an IP header. This header is used to deliver the packets to the destination host. IP was designed as a protocol with low overhead. It provides only the functions that are necessary to deliver a packet from a source to a destination over an interconnected system of network. So IP is connectionless, meaning that no dedicated end-to-end connection is created before data is sent. Connectionless data communication work on the same principle. It IP requires no initial exchange of control information to establish an end-to-end connection before packets are forwarded. IP operates independently of the media that carry the data at lower layer of the protocol stack. So IP packets can be communicated as electronic signal over copper cable, as optic signal over fiber, or wirelessly as radio signal. IPv4 packet header consists of fields containing important information about the packet. These fields contain binary numbers which are examined by the layer 3 process. The binary values of each field identify various settings of the IP packets. So there are significant fields in the IPv4 header include version. It contains a 4 bits binary value set to 0100 that identifies this as an IP version 4 packet. Second one is the differentiated service of diffserv or the DS, formerly called the type of service or the TOS field. The DS field is an 8-bit field used to determine the priority of each packet. The third one is the time to live or the TTL contains an 8-bit binary value that is used to limit the lifetime of a packet. The third one is the protocol field is used to identify the next level protocol. This 8-bit binary value indicates the data payload type that the packet is carrying. Port 1 is source IPv4 address contain a 32-bit binary value that represent the source IPv4 address of the packet. Destination IPv4 address contain a 32-bit binary value that represent the destination IPv4 address of the packet. So, limitation of IPv4 through the years, IPv4 has been updated to address new challenges. However, even with challenges, IPv4 still has three major issues. These are IP address depletion, the internet routing table expansion, and the lack of end-to-end connectivity. So, introducing IPv6 is the early 1990s, the Internet Engineer Task Force or the IETF grew concerned about the issue with the IPv4 and began to look for a replacement. This activity led to the development of IP version 6 or the IPv6. Improvement that IPv6 provides include increased address space, improve packet handling, eliminate the need for NAT, and that's all. Encapsulating IPv6 is one of the major design improvement of IPv6 over IPv4 is the simplified IPv6 header. IPv6 packet header, the field in the IPv6 packet header include version. This is the field contains a 4-bit binary value set to 0110 that identifies this as an IP version 6 packet. Second one is the traffic class. This 8-bit field is equivalent to the IPv4 differentiated service or the DS field. Third one is the flow level. This 20-bit field suggests that all packets with the same flow level receive the same type of handling by routing. Fourth one is the payload length. This 16-bit field indicates the length of the data portion or payload of the IPv6 packets. The fifth one is the next header. This 8-bit field is equivalent to the IPv4 protocol field. It indicates the data payload type that the packet is carrying, enabling the network layer to pass the data to the appropriate upper layer protocol. The sixth one is the hop limit. This 8 field is replaced the IPv4 TTL field. This value is incremented by a value of 1 by each router that forward the packet. Is when the counter reaches 0, the packet is discarded. The seventh one is the source IPv6 address. This one 28-bit field identifies the IPv6 address of the sending host. Destination IPv6 address. This 128-bit field identifies the IPv6 address of the receiving host. So, host forwarding decision, another role of the network layer is to direct packets between hosts. A host can send a packet to first one itself, second one to a local host, and the third one is remote host. So, default gateway. The default gateway is the network device that can route traffic to another network. It is the router that can route traffic out of the local network. So if the analogy that a network is like a room, that the default gateway is like a doorway. If you want to get to another room or network, you need to find the doorway. Host routing table. On a window host, the route print or netstat -r command can be used to display the host routing table. Both commands generate the same output. The output may seem overwhelming at first, but it is fairly simple to understand. Entering the netstat -r command or the equivalent route print command display three sections related on the current TCP IP network connection. Interface list the media access control or the MAC address and assigned interface number of every network cable interface on the host, including Ethernet, Wi-Fi, and Bluetooth adapter. IPv4 route table lists all known IPv4 routes include direct connection, local network, and the local default route. IPv6 route table lists all known IPv6 route including direct connection, local network, and local default route. Router jacket forwarding decision. When a host sends a packet to another host, it will use its routing table to determine where to send the packet. If the destination host is a remote network, the packet is forwarded to the default gateway. So the routing table of the router can store information about. First one is directly connected routes. These routes come from the active router interface. Second one is the directly connected routes. So these routes come from the active router interfaces. Third one is the remote routes. So these routes come from remote network connected to another router. So the last one is default route. Like a host, router also use a default route as a last resort if there is no other route to the desired network is the router table. IPv4 router routing table. So on a Cisco IS router, the show IP route command can be used to display the router IPv4 routing table, and in addition to providing routing information to direct connected network and remote network, the routing table also has information on how the route was learned, the trustworthiness and rating of the route, when the route was last updated, and which interface to use to each the requested destination. Directly connected routing table entries. When a router interface is configured with an IPv4 address, a subnet mask, and is activated, the routing to table entries are automatically created. So these are the C identifies a direct connected network, and the L identifies that it is a local interface. A router is a computer. There are many types of a infrastructure router available. In fact, Cisco routers are designed to address the needs of many different types of business and network. Branch, teleworker, small business, and medium-sized branch size. 1. The large business organization and enterprises. And the service provider. The large service provider includes Cisco ASR, Cisco CRS3 carrier routing system, and the 7600 series router. Router, CPU, and OS. Like all computers, tablets, gaming console, and smart devices, Cisco device requires a CPU to execute OS instructions, such as system initialization, initialization, LAN and WAN interfaces. Similar to Cisco switch, there are several ways to access user exec mode in the CLI environment on a Cisco router. These are the most common. Number one is console. This is the physical management port that provides out-of-the-band access to a Cisco device. 2 is the secure cell, or the SSH. Is a method for remotely establishing a secure CLI connection through a virtual interface. The third one is the telnet. Telnet is an insecure method of remote establishing a CLI session through a virtual interface. Router boot up process. There are three major phases to the boot up process. First one is to perform the post and load the bootstrap program. Second one is locate the load the Cisco iOS software. Third one is locate and load the startup configure file or enter setup mode. So configure router interface. For router to be reached, the in-band router interface must be configured. There are many different types of interfaces available on Cisco routers. In this example, the Cisco 1941 router is equipped with 2 gigabit internet interface and a serial 1 interface card or WIC consisting of two interfaces. Verify interface configuration. There are several commands that can be used to verify interface configuration. The most useful of these is show IP interface brief command. The output generates display all interface, their IPv4 address, and their current status. So you can verify connectivity from the interface using the ping command. So other interface verification command include show IP root. So this display the content of the IPv4 routing table stored in RAM. Show interfaces. So this display static for all interface on the device. Show IP interface. So this display the IPv4 statistic for all interface on the router. So the network topology consists of the router interconnecting two separate LANs, so device is configured with the appropriate default gateway address. So this is all the summary of chapter 6 entitled Network Layer. Thanks for watching. See ya!